Hi guys, let's talk about plate tectonics. First, I want to review the layers of Earth, right? We talked about the crust, we talked about the mantle, we talked about the outer core and the inner core. We're basically going to mainly focus on the mantle now and the crust and how the mantle affects the crust. Basically, what's happening is called continental drift, right? What's happening here is that the crust, right, is broken up into pieces and it's floating up above the mantle, on top of the mantle. And the mantle is moving, right? These convection currents are kind of stirring in the mantle and they're moving the plates on top of it to basically cause the different plates to move, right? The different continents to move, and that's called continental drift. So where are they going, right? Here's how they are moving right now. We have some plates that are separating from each other, right? Like here in the Mid-Atlantic Ridge. We have some plates that are crashing into each other, like the Nazca plate and the South American plate. We have some that are sliding past each other. So there's like all kinds of different movement, and we're going to learn about each type today. Here's a version from your textbook that I need you to cut out and glue into your journal. And you can also see the arrows here showing how some plates are separating, some plates are crashing into each other, and some plates are sliding past each other. Here's another one that shows you kind of the bathymetry and the topography of Earth, right? You can see the Mid-Atlantic Ridge right here, where we have a divergent plate boundary. They're spreading apart right there. This is Pangea. Pangea existed about 200 to 250 million years ago or so, and it was one supercontinent. What basically happened is we looked at what Earth looks like today, right, which is down here at the bottom, and we saw where the arrows were going, and like in the pictures that I just showed you, and we kind of pretended to hit rewind. What would happen if we rewound and we saw what things used to look like? Well, it used to look like this, right? 200 million years ago, we had a supercontinent called Pangea. And then over time, it separated into Laurasia and Gondwana land. And then, later on, it separated some more, right? And basically, we have what we have today, present day Earth. And it's still kind of separating out and still moving around today. How fast is it doing this? It's basically doing it at the same rate that your fingernails grow. So think about like if you did not cut your fingernails for an entire year, right? They would grow to about 3 to 5 centimeters long. And so that's kind of what's happening here. The plates are moving at about 3 centimeters per year. Okay. So it's very little. Some plates move faster than others. So there's like more, spreading apart or growing or whatever, in different, places, but, some of them move slower. So on average, it's about 3 centimeters per year. How do we know that this is happening? How do we know that Pangea existed, right? Besides kind of pretending to hit rewind and see what it used to look like. Well, we have fossilized evidence, right? We have animals that we can find fossils of that lived on 2 separate continents that are now separated by an ocean. For example, look at Africa and South America, right? We have fossilized evidence that this species of dinosaur or this species of plant, right, lived in this area. We find fossils for this guy here and the same species over here, right? This guy, we find fossils here and also over here. And so we know that they lived on both continents, but how is that possible if they're separated by an ocean? Well, it's because they didn't used to be, right? We hit rewind and we see that these actually fit back together, and we know that they could just freely move back and forth because these land masses were connected at one point in time, about 250 million years ago. What is causing the movement? Convection currents. So this is a review of what we talked about when we did layers. We have these convection currents. The magma in the mantle is getting heated by the core because there's a lot of pressure here, lots of gravity, right? Pushing everything towards the center. So this is really, really hot. It heats the molten magma here. And so when stuff is hot, it floats up, right? Just like the hot air balloon. So the magma, the hot magma floats up and then it cools. When it gets close to the surface here, it cools down and it doesn't have anywhere to go. It can't go back down the same way, right? Because it's like a highway. All the traffic is going up. So it has to find a way to come back down. So it comes back down and makes this current. Gets hot, floats, cools, sinks. Hot, Floats, cools, sinks, right? Over and over again. And then this one's going to go in this direction, right? So this is hot and then gets up here, gets cool, gets and then sinks and gets hot again, right? And so on. And so it's going to make the plates on top move in that direction. So it's kind of like a floaty on a river, right? You put the floaty in the river and the river goes with the floaty goes with the river water. And so that's going to push along these plates up above it, right? This magma is going to push along those plates in different directions. And so you can see here they're spreading apart, here they're crashing into each other, and in some places they slide past each other. Here's another view, right? You can see the separation happening here. You can see the crashing together happening over here. So Earth is divided into plates, right? We call this the lithosphere and the asthenosphere, okay? And basically the asthenosphere, right, is the magma right underneath these plates that are going to be moving. So make sure that you pause and copy this, right? The lithosphere is the cool, rigid outermost layer of Earth, right? It is broken into thick pieces called tectonic plates, and the plates are what's moving. Here is a map. I'm gonna make it a little bit bigger so that you can see what all the different parts are, and I want you to go ahead and label this in your notes. So go ahead and push pause. Here's another view of the different plates, right? We didn't label all of them, but there's a lot of plates out there, right? There's a lot of stuff happening and they're all moving in different directions. So we have some like main plates like the African, the South American, the North American, but then we have some smaller plates like the Nazca plate, the Scotia plate, the Arabian plate, and so on. So let's go on to the next page of our notes, right? All of this was discovered by a guy named Alfred Wagner. And he actually figured out that the plates were moving, but he did not know about convection currents back then. So a lot of people didn't believe him because he knew that the plates were moving and he proved that they were moving, but he could not prove or figure out how they were moving, like what was causing the movement, which ended up being convection currents, right? He did not know anything about the convection currents. He just knew that the plates had been moving. These are the three types of plate movements, right? Convergent is when the two plates collide, so convergent collide or crash. Divergent is when the two plates divide or move away from each other. And then transform is going to be when they slide past each other. Convergent, divergent, and transform are the three ways that they move. Here is our model of convection currents, right? Again, inner core, outer core, right, is going to cause movement in the mantle, and then that's going to affect the lithosphere. We need to label our magma up here where it says magma for our divergent boundary. And then let's talk about divergent, right? I need you to fill in the example onto your notes. An example here, right, where we have two plates that are separating or spreading apart is the Rift Valley in Africa. The Atlantic Ocean is another place where plates are actually separating from each other. So here's a picture of the Rift Valley. And here's basically what's happening, right? We have these two plates separating and creating kind of a valley here. The magma comes up and fills in that space in between to make really what's Earth's newest crust, right? It's just basically barely born crust. Here is the Atlantic Ocean, right, which we call the Mid-Atlantic Ridge. So actually right now, South America and Africa are getting further and further away from each other. North America and Europe are getting further and further away from each other. Again, about 3 centimeters per year. So the Atlantic Ocean is actually still growing. Here's how it started, right? This is, you can imagine dinosaurs living here on this land and they're just going back and forth, living their dinosaur life, right? Back and forth, back and forth, back and forth. And then over thousands, millions of years, right? It split and got wider, filled in with water, got wider and wider. And now it's basically what we see as the Atlantic Ocean today. And you can see the magma coming up from underneath and filling in the gap and making brand new crust right here. Transform plate boundaries are going to be when they're sliding past each other. And an example of this is the San Andreas Fault in California, right? And this is what causes earthquakes. So you guys have heard of earthquakes in California, right? This is why they happen. So transform plates are sliding, right, past each other. And I need you to write down the example as being the San Andreas Fault. Here's what it looks like a little bit kind of closer, right? We have the plate boundary right here, and they're sliding past each other. You can see this here. Here's an actual picture of the San Andreas Fault. Then we have convergent, right? The more dense plate is going to be forced underneath, which is called subduction, in a convergent boundary, okay? So I have oceanic crust here, right? This is the ocean right here, and this is continental crust, land. And so this is going to be more dense because it contains water, and so it's going to get pushed underneath, and then it's going to actually melt right here and erupt as volcanoes. This is how Mount St. Helens happens. This is also the Himalayan mountains. This is how they were formed because of a convergent plate boundary, a subduction zone. So let's go ahead and write down Mount St. Helens as our example here. Again, here, this is continental, so we can have this as well. This is kind of the more like the Himalayan mountains, right? Because India crashed into Eurasia. And so here we have land, two pieces of land coming together, right? And making these mountains here. Here's what it looked like a long time ago, right? 71 million years ago, India was basically an island, right? And it kind of scooched closer and closer and closer until it crashed into the Eurasian plate, and we got the Himalayan mountains right here, one of which is Mount Everest, right? The tallest mountain on land in the world. Then I wanted to mention really quick just about subduction zones, right? Subduction, right? Sub means to go underneath. So this one's being subducted underneath another plate, and then this melts and comes up to make a volcano right here. So here's what's happening here, right? I have oceanic crust here being subducted underneath, lots of heat and pressure right here, so it melts and it erupts and becomes usually a volcanic chain. Like the Andes Mountains. These are the Andes Mountains in South America. So how do we know that this is happening? Okay. First, right, we have mountains in Africa that match up with the mountains in South America. When the two continents were stuck together, right, the mountain chain actually lines up. We find fossils, right, in several places that are separated by the Atlantic Ocean now. But we know that they at one point were connected and the animals could go back and forth, right? And then also climate, right? We find evidence of fossilized plants in Antarctica. It's too cold in Antarctica for plants, right? But it's because Antarctica used to be closer to the equator. And so back then it was warm enough for plants to live there because it was in a different place on Earth. And now it's moved to the South Pole and it's really cold there. Plants don't grow there now. Okay, this is going to go in your notes. Pause to fill it in. But basically it's all a review of what we just talked about. So I'm going to switch to a picture so I can show you and review this. So convergent, right, is when they crash together, right, and it makes mountains. Divergent is going to be when they divide, okay, so for example, right here, and that's going to make rifts, right, and then transform is when they slide past each other. That's going to cause earthquakes, and then subduction is when one goes underneath the other, right, and that is going to make volcanoes. Thanks for watching, and let me know if you have any questions.